Alright, so this video is about factoring quadratic equations, and I'm going to use 3 examples to illustrate how to do this. So, first example looks like this. X squared plus 11x plus 28. So the way to factor this is first you have to draw these sets of parentheses here, right? Because remember, a trinomial is the product of 2 binomial factors, or a second degree polynomial is the product of 2 linear factors, okay? So the first step in doing this is I need to write my x here and my x here, because these are the factors of the first term. This is the first term, this is the second term, and this is the third term. So the factors of the first term go here and here, okay? Because an x times an x is an x squared. Remember that when we're factoring, what we're doing is we're really doing reverse FOIL. We're going FOIL and reverse. Instead of taking 2 binomials, meaning this is a binomial and this is a binomial, instead of taking 2 of these and multiplying them to make 1 of these, we're taking 1 of these and breaking it down to make 2 of these, okay, right? So x times an x is an x squared, great. So now what I need to do, just like I put the factors of the first term in the first positions, I need to take the factors of the last term and put them in the last positions. So I'm going to think of all the numbers that multiply together to make 28. So while I know that 28 and 1 makes 28, right, if I multiply it, I know that 14 and 2 would work, and I know that 7 and 4 would work. See, because 14 times 2 is 28, 7 times 4 is 28. So I'm just thinking of all the pairs of numbers that when I multiply them make the last term, make 28. Okay, now, once I've done that, though, how do I know which of these pairs of numbers to use? Okay, because ultimately what I'm going to do is I'm going to take one of these pairs of numbers and I'm going to put it here and here. So, but I need to know which one is the correct one. And the way that I know that is I think about which one of these numbers, or which one of these pairs, if I added the 2 numbers together, would give me the middle number. Because remember, so the 2 conditions that one of these pairs has to satisfy in order to be the right one is that the 2 numbers must multiply together to make the last term. They need to multiply together to make 28. And simultaneously, at the same time, they need to make 11 if you add them together. So those are the requirements. They need to multiply to make 28 and they need to add to make 11. So tell me which one of these pairs of numbers, 28 and 1, 14 and 2, or 7 and 4, would satisfy that condition. 28 and 1 wouldn't work because that would give you 29. 14 and 2 wouldn't work, that would give you 16. So it has to be 7 and 4, because 7 plus 4 is 11, and 7 times 4 is 28. So that's why I'm going to put positive 7 and a positive 4 right here. So I'm done. That's my answer, right? And I can check myself, by the way, by just doing FOIL. So if I go x times x, I get an x squared. If I go x times 4, I get a 4x. 7 times x is a 7x. 7 times 4 is 28. And then if I simplify by combining like terms, I get x squared plus 11x plus 28. Oh, look at this, no surprise. This is the same thing we started with, because all we've been doing this whole time is just rewriting this equation. This is the multiplied out form, this is the factored form, okay? And I can go backwards and forwards. I'm just remembering that I'm doing reverse FOIL when I'm factoring, okay? So, cool. That's the second, that was the first example. Now let's look at a second example, because this can get a little more complicated if you introduce negative signs into it, because this was easy because it was both positive numbers, okay? So I want to show you how it gets a little more complicated when you put a minus sign, when you get a minus sign involved, okay? So let's look at this example. This is example 2. X squared plus x minus 6. Okay, so this is my quadratic expression, this is my trinomial, and I'm going to factor it, again, into 2 binomial expressions, 2 binomial factors. So the process is the same, okay? I put an x and an x, because these are the factors of the first term. Now I need to think of all the possible pairs of factors of the last term. So this is where it gets a little tricky. See how this is a negative 6? This negative sign goes with the 6 here, right? So this is a negative 6. So I need to think about things that actually multiply to make a negative 6. Well, negative 2 times positive 3 would give me negative 6. So I know this is a pair of factors. Just like positive 2 and a negative 3 would also give me a negative 6. So it's almost like I have to think about 2 and 3 twice. One in which the 2 is negative and one in which the 3 is negative. Okay, but there's still more, right? There's 6 and negative 1, and then there's negative 1. Excuse me, I screwed that up. There's negative 6 and positive 1, right? So I need to think about which pair of factors here would combine together, would add together to make a positive 1. See, because just like up here, see how I had to look at which pair of factors would add to make 11? It's the same thing. I need to think about which pair of factors would add to make a positive 1. And the reason I'm saying positive 1 is because isn't there sort of like an imaginary 1 here, right? This is sort of like 1x, right? So I need to just look at this, right? If I took a negative 6 and a positive 1, negative 6 plus positive 1 is negative 5. Nope, doesn't work. What about positive 6 and negative 1? 6 plus negative 1, 5. Nope, doesn't work. How about 2 and negative 3? 2 plus negative 3 is 2 minus 3, so negative 1. Nope, doesn't work because this is a positive 1. So it has to be this one. Let's see. Negative 2 plus 3 is positive 1. Yeah, so these are my factors. So all I do is I just take these numbers and I put each one of these numbers in a slot. So negative 2 is going to go here, and positive 3 is going to go here. Excellent. So this is the factored form, and if we checked it, again, we would get the same result. See, x times x is x squared. X times 3 is positive 3x plus 3x. Negative 2 times x is minus 2x. And negative 2 times positive 3 is negative 6. Combine like terms, positive 3x and negative 2x give me a positive x, and then negative 6. Great. So check it out. This is what I started with. This is the same as that. Wonderful. Cool. So I did it right. Okay. So the third example, I'm going to throw 2 extra things at you here, okay? And this is sort of the most complicated version of this factoring quadratics that you're going to run into in basic algebra, right? And I'll just show you, okay? It's much easier to show an example than it is to try to explain it in words, okay? So let's say that I had an equation that looked like this. 6x squared plus 27x minus 15. So there's all kinds of stuff going on here. So what's the first thing that you notice about this equation or this expression that's different? See how this beginning term here is not 1? See how this is a 6? See how like here there was no number in front, right? This was just x squared. So this changes things just a little bit when you have a number in front of the x squared, okay? You have a coefficient of the x squared, okay? So, but it's still doable. And the first thing you want to do is you want to try to factor out, when you see this, you want to try to factor out a greatest common factor of 6, 27, and 15, because that's really going to make it easier to factor if you can pull out a common factor. Notice, see how 3 goes into each one of these numbers, right? See how 3 goes into 6, goes into 27, goes into 15. I'm going to start this simplification process by taking a 3 and actually just pulling it out of this expression. So if I take out a 3, I'm going to be left with 2x squared, right? Because 6 over 3 is 2. Okay, if I take a 3 out of 27x, I'm going to be left with a 9x, right? Because 27 over 3 is 9. And if I go 15 over 3, that's going to be negative 5, right? Because all I did, look at this, I just factored out a 3, okay? Because that was the greatest common factor among these 3 terms. So now this is a little bit nicer, because what I can do is now I can just simply factor this remaining trinomial and sort of ignore the 3. The 3 is just going to stay out here and just kind of chill. It's not doing anything. It's not going to make our lives more complicated by having this be a 6 and a 27, right? So now though there's sort of one more added complication, okay? So now that we factored out the 3, there's something else you have to worry about, and that is these numbers right here, okay? In previous problems, like up here, this was just an x and an x. I don't know if you can see that, yeah. This was just an x and an x because this was just an x squared. However, since this is now a 2x squared, I need to put a 2x and an x. Because remember, these two things right here need to multiply together to make this. So 2x times x is 2x squared. That's why this needs to go here. Does that make sense? I hope it does, right? If not, rewind the video, because you have to understand this, all right? So 2x and an x go here because 2x times x is a 2x squared, right? Okay, now that we've gotten that out of the way, I'm just going to go into my normal process like I've been doing. I'm going to think of factors of negative 5. So negative 5 and 1 is a pair of factors, right? 5 and negative 1 is a pair of factors. And that's about it, actually, because it turns out 5's a prime number, so it makes our life easy, okay? We don't have to worry about lots of pairs. These are the only pairs of factors that exist, of whole number factors that make -5, right? So, question is, so what's going on here, right? Because maybe you see a problem. Do you see how -5 and 1 would make, what, like a -4? Well, that's not a 9. Remember, I'm trying to make the middle term by adding, and then a 5 and a -1, that would give me a +4. Neither of those numbers are 9, so what's going on here? Is this factorable? What's the problem? Did I use an example that wasn't going to work? No, it turns out this actually is going to work, but you have to do an added layer of complexity. And that complexity has to do with the fact that this is a 2x, okay? So really, this is a little complicated, okay, but I'm going to try to say this in the most concise way as possible. When you're factoring trinomial equations, trinomial expressions, that have a coefficient on the x squared term that is not a 1, meaning that it's some number that's like a 2 or 3 or 4, right? In this case, it's a 2. If you're in this situation, you need to think about factors of the last term that multiply with factors of the first term to add to make the middle term. I'm going to say that one more time, okay, in the context of this problem. I'm trying to think of pairs of factors of -5 that multiply with pairs of factors of 2x squared, and then after I do that multiplication, I'm going to add them together and they're going to make a 9x. Okay, so that's the long way of saying it. The short way of saying it is I just need to basically think about the fact that one of these, whatever pair of factors I choose, one of those numbers is going to get multiplied by a 2. Okay, so I'm just going to do this, and then I'm going to do the FOIL afterwards, and I'm going to show you why this is, okay? Turns out that if I chose this pair of factors right here, 5 and -1, this is actually going to be the one that works. I'm going to show you why. Because if I take a -1 and I put it here, and I take a +5 and put it here, see, this is the -1, this is the +5, this is actually going to be the correct answer. And the reason is because, do you see how in FOIL, when you're doing FOIL, what you do is you go 2x times x. That's going to give me my 2x squared. Now here's the key. This is why I needed to worry about this too. Because do you see where I go, when I go 2x times +5, I'm actually going to get a 10x. And then I'm going to go -1 times x, it's going to give me a -1x, right? And then -1 times 5 is -5. You see how these two right here, this positive, oh, excuse me, I'm sorry, this is supposed to be a x, I left that off. Sorry. Do you see how this 10x and x actually combine to make a 9x? And this is -5, and this is 2x squared. Do you see how this is the same as that? Oh, and by the way, I'm actually making a mistake right now. I can't forget about this 3. This 3 is still here. But do you see how when I sort of re-multiplied these two factors, I would actually get back this same expression here? So do you see why it was important that I worried about multiplying one of these numbers by a 2, this 2, before I added them together to make the middle term? This is one of those things you really have to just do a bunch of these problems and you'll kind of begin to understand why it's important. So this is the hardest type of problem to factor, when you have both a negative and a positive, and you have some number here that's not just a 1, okay? You have like a 6x squared. That's sort of, it can get really complicated. So I'm just going to do a real quick recap, okay? And because I feel like this was a really long video, but this is definitely a complicated subject. So first thing we did, we had a simple example. We had both of these signs were positive. All we did, we thought of factors of 28 that add to make 11. Turns out 7 and 4, filled it out, boom, we're done. Okay, second example, the only complication we introduced was that one of these signs is now negative. So we had to think about all these pairs of factors now, considering the fact that one of them is going to be negative, right? So we had -2 and 3, 2 and -3, so on and so forth. Figured out that if we take a +3 and a -2, that's going to give us our 1x. That's what we needed, okay? Third example was the ultra complicated one. Not only did we have to begin by factoring out a 3, right? Taking the 3 out of every single one of these terms because it was the greatest common factor, we actually had to think about now what the consequences of this 2x squared were going to be. We had to put a 2x and an x as the initial term of each one of these binomial factors and think about how that was going to affect multiplying each one of these factors before we added it to get our middle term. Okay, oh, I forgot to put a plus sign there. Okay, so anyways, that's basically the recap. That was definitely long, rambling, but I hope that made sense to you, and I hope it would help you out when you're trying to do this. So anyways, thank you for watching. Please check out my other videos, and if you really like them, please subscribe.